For our experiment today, we are going to submerge a block of water, a block of water, a block of wood in water, and using the forces acting on it, namely the buoyancy force and the weight, we're going to solve for the mass. We've previously weighed the block and calculated the mass to be 0.968 ounces, so we should get something very close to that. Alright, here goes. First, we draw a free body diagram. Water. Block. There are two forces acting on this body. They are concurrent. Buoyancy force and weight, which equals mass times gravity. The sum of the forces acting on a body, in this case the buoyancy force, which is acting up, minus the weight acting down, equals mass times the total acceleration. In this experiment today, we are going to try to solve for the mass of this wooden block. To do this, we're going to use a few of the fundamental equations of physics. The first one is this one. In this case, our y naught, which is our starting position, equals 0. Our initial velocity is going to be 0, so those first two terms cancel out. And we're left with y equals 1/2 at squared, solved for a.
I can't do the math.
You can do this.
So wait, it's 2y.
I don't think we should skip any steps, to be honest.
So you want me to just write?
Rewind.
You can cut it out. Whatever.
Nothing will be cut out.
2
We release an unedited version.
over
Live and
a.
uncut.
Oh no, we're solving for a.
You had one job, Cassandra.
Shut up!
And just like that, we have a equals 2y divided by t squared. We know y, and all we need to do is measure t. This is the buoyancy force, the volume of the block times the density of water. By definition, the buoyancy force acting on any object is equal to the weight of the water displaced. Alright, now we have a few known values that we measured. We know that the block of the wood that we're testing is 2 cubic inches. It's 1 inch by 2 inches. We also know that the depth of this water, or in this case our y, is 17 inches. Because we're going to be submerging the block to the very bottom of the water, our y naught, or original y, is 0. And because Matt is going to be holding the block stationary before releasing, our initial velocity is also 0. So now we're going to submerge the block to the bottom and time how long it takes to flow to the top.
Ready? Let it go. 1.12 seconds.
Okay, so it took 1.12 seconds for the block to float from the bottom to the top.
You want to do a few more trials?
Sure.
Go. That was 1.18 seconds.
Okay, let's do one more.
Go. That one was 1.38 seconds.
It's an outlier.
Yeah, you want to do another one?
One more.
1.25 seconds.
Okay. We can average all of these. We have our known values written down. And we're ready to solve our equations. Okay, so here we have all our final calculations. These are our known values converted into the imperial units. And this might look crazy, but this is actually in reality just our initial equation. The sum of the forces equals ma, which equals the buoyancy force minus the weight, or mass times gravity. We input our terms for acceleration and the buoyancy force. And over the next couple lines we isolate mass, input the numbers, plug it into our calculator, and it gives us 1.76 times 10 to the negative 4 blobs, which we learned is actually a unit. Convert that into pounds, 0.0682 pounds, into ounces, which equals 1.09 ounces. This presentation was brought to you by Matt, Cassandra, and Gregory McNeil. That's all, folks.